Hello, hello, hello. It is good to see you all today. We are back to the grind, almost to our last lecture for this class, which is pretty great. I am trying not to be distracted in my office with everything around me. So let us dig in. Today we are talking about population sampling and sample size estimation. So there are a few things with this that we are going to discuss, and before we dig into that, we have to know a few definitions. Let's start there. A few definitions. One, our target population is going to be the group the study aims to research. So, for example, diabetic patients over the age of 50 living in rural areas. So that in itself already gives an inclusion and exclusion criteria to what we are looking for. The source population is the subset that we actually study from the target population. So maybe you are doing rural individuals in Pickens County, Alabama, or Lynchburg County, Virginia, and this is this subset that we are getting into, instead of all of the people in all of the 50 states. Sample population is the individuals we've recruited to the study. So the ones that we have said, please come and be part of our study. And then the study population is those who actually consent and qualify to be in the sample population. So you can tell it gets smaller and smaller. So we have this idea of, we have this huge target population, then we have the study population, then we have the sample population out of our initial quantities. A sample is a smaller, hopefully respective. I feel like I just need to start this video over, but we're not going to do that because I think it would get worse. Okay. Hopefully representative collection from the population that determines why do we sample, resources, time, money, workload. We can't always get all of them. But then we can also look at mathematical accuracy and how this then infers back to that total population. So it works out really well. We want to use that hypothesis study or question to identify the target population. So for example, right now I'm doing research with a friend, and we are doing Black professional women, and we are sampling from the Alpha Kappa Alpha, aka sorority, because we know that this is something that she is able to access, as well as that we will get a good quality sampling of professional Black women. And so this is like, that's, in our hypothesis and our questions, this is what it looks like. This is normally not possible to get the entire target population. And so this is where we go from this whole to the sample, right? We want it to be indicative. Ideally, we want it to be also laid out the best that it can. So it's getting quantity of male to female, race, ethnicity, maybe even socioeconomic status, things like that. So we are going to think about how to possibly bind this as well if we are looking within a certain thing. So this example is giving within a nuclear power plant, and this is something that back home that we talk about is there's a nuclear power plant called Hanford. And so we are going to want to sample within that area, and like this is saying floodplains, things like that may have been affected, to be able to get down to that sample size. So understanding how this acts as a binding and kicks some other things out. So how do we determine this? A lot of times this is determined through your study, whether it is things that you have collected in the past, things that you have discussed with colleagues, things that you have mulled over in the back of your mind. Maybe it is people you've worked with before, or I think one of the things that it was interesting to me when I did Lego research, because one of the things that was brought up was, why don't we do this among veterans because veterans could use alternative methods of stress reduction. So, I mean, it's that previous study, and we're seeing like it could go here. We are seeing a conversation and saying it could go here. And so sometimes it really just depends on, maybe you have found a whole bunch of research studies in one area, but not about that. So with my friend and I, we found a bunch of studies with a lot of different, like how diversity affects recidivism in youth and things like that, but it wasn't specifically asking about from a professional Black woman's population. So, so here are factors that influence the representativeness of the sample size. So sample size itself. So how many, if we only have a small amount, especially when we're talking about qualitative, it is harder to get a representative sample because you're talking about a small amount of people that you are interviewing. Sample procedure, especially with things like snowball or convenience sampling, we're going to end up with very specific sections. So for example, here at Fort Lewis College, if I was to do convenience sampling, a lot of it's going to come from our health sciences. So it's going to be exercise science, nutrition, public health. And it's going to really leave out like business and business, maybe some psychology, biology, chemistry, things like that. And so it's going to leave a lot. And then what is the response? And response may be due to what different incentives are there for individuals. So the next question is, when should I sample the entire population? When it's small, when you're able to do that. If you have a lot of resources and are able to do that, and you don't expect a high response. So that's sending out a survey to the whole campus population would be when you would do that. Population is, so the population may not be the same as the that we draw from is not necessarily the population that we want the information from. So we need to change that. Sometimes they might be completely separated, or we are accepting like animal data for understanding human health because of the samples, the procedures we're going to run. Other things may be things like medical records or other things like that that can help. And then we also want to think about our type of study that we're doing. Is it population-based? Is it probability or non-probability? Is it convenience? And what does that look like? So how do we actually get the people? So we can do, so this is for probability, simple random sampling where each person has an equal chance of being selected. We can do systematic sampling where maybe we alphabetize everybody and we say every third person is going to be, we can do stratified where we are looking, we have specifically pulled out this person is part of this group and this person is part of this group, and very systematically pulled out, like we need these people from these groups. We can do cluster, so maybe it's geographic, maybe it is religious, maybe it is race or ethnicity. Then we can do multi-stage where we are doing sampling, get the data, sample again, get the data, things like that. So with simple random sampling, this is going to be small population, it's going to be homogeneous, it's going to look same across, it's going to be readily available. So this could be like I said, me going into our department. Each element of sampling frame has equal probability of selection or volunteer. The greatest number of possible samples. However, we sometimes see where interest, minority subgroups may be not part of it. Like I said, if I was to sample here, I'm going to get a lot of ES or HS, but not a lot of business administration or education. Systematic arranges the population according to an ordering scheme. And then we are going to look at, for example, the 10th name in the telephone directory. Bias can occur that we don't understand, or hidden patterns in this, so we want to be careful of that. And then stratified, I mentioned, is looking at different categories to be able to get like adequate representation for minorities and things like that. But it may require a larger sample size to be able to get all of those. And it may reduce usefulness. After the stratification, we may have to go back and do that again. So we should stratify based on education level, or sample cancer patients based on a cancer stage or severity. So it can be tough. Cluster is going to be sampling units as groups, so this could be sampling a class or a dorm. However, it is not necessarily going to be equal across all populations. So there may be sampling errors that take place. If we're looking at a dorm, there may be something wrong with the dorm that is messing with sleep patterns, so it's not getting a good thing right here. If I'm asking different classes how they're doing, a chemistry class might notoriously, if I'm only asking chemistry, might say, pfft, whereas a fun dance class may be always like, so we kind of want to think about those too. Strata and clusters are both non-overlapping subsets of population. Strata are represented in the sample, but only a subset of this. So we want to kind of think about, what does this look like across all stages. So multi-stage sampling is a process by taking random samples of preceding random samples. So continually doing these randomizations. It can be very useful. However, we want to be careful because of when the populations are not appropriate for what we are doing. So here's a good example. We have the East District of Delhi, and then we look at 3 sub-districts, and then 1 sub-district, and then the wards within that district, and then we look at some of those. And so we keep getting smaller and smaller until we get to 24 for the study. We want to think about bias as well. The chance of being selected is not equal in non-random bias. Ascertainment bias is convenient sampling, where it's not representative of the whole. So sometimes in like snowball sampling and stuff like that, it's not going to be representative of the whole. Non-response bias is those who participated are markedly different than those who choose not to. Bias is not always random. Most of the time we see this in a consistent direction. So if I'm asking people to do a physical activity test, most of the time the people who are going to participate in it are people who are already physically active, because people who are not get nervous about things like that. So we kind of want to think about, what does that look like overall, and how do we work through that process? Sorry, you guys, this is driving me nuts here. We also want to think about vulnerable populations. So people who are in prison, who are handicapped, children, they don't have the ability to give as trusted, informed consent as normal populations, and people in prison are often swayed easily by incentives. So we kind of want to think about that. When we're talking about handicap, even talking about developmentally delayed or people who are mentally disabled, we want to think about populations who may not understand what we're talking about. And this is why having the language be at a lower level is really important, maybe 6th or 8th grade level. But it can be problematic when they are not studied. Pregnant women and children, we have to be careful because of safety and pharmaceutical things, but we also want to make sure that they are included. So there's some really big concerns in these, and what adverse effects might take place. So coercion is another big thing. We want to make sure we are free of coercion. So most of the time in this discipline, we are going to do community-based participatory research, where we are working with communities to identify needs, do a needs assessment even, look at priorities, find proper study designs. So right now that may be something that we are studying here on our campus that we would want to look at the cultural design to make sure that it's appropriate for Native American individuals. Apply the findings to public health policies. Remember, these don't have to be necessarily public health policies that are nationwide or worldwide. These could be campus-wide. And then think about the programs that can be established for this. A larger sample size is going to generally be more representative of the true population. So we can use a sample size estimator to find what we need, and then power estimation. And when we have a power of 80% or greater, then we have an adequate amount, especially for grants. With power estimation, it's great. I mean, if you have a statistician, I had a great statistician, Dr. Leeper, in my dissertation was amazing. And so he really helped me with these along the way. But a type 1 error is believing a researcher found significance when there is none. And a type 2 error is stating that there's not a difference when there actually is a difference. And so type 1 error is the type that we are the most concerned about when we say that there was a difference when there actually wasn't one. So making sure we have enough people to not overlook that is really important. And then if we are looking for this is for a sample size based on 80% power. This has a 79.8% power, so really close. I think we could take it. This would be how we would do this. Most of the time we do this through SPSS or with a sample size estimator. And that is it. We will expand a little bit more on Wednesday in class and talk about this. Please be ready to discuss it. Well, hang on. This will be more of a review if you need it. Sorry. Thank you guys again so much for all you do and being part of this class. I appreciate it. I know it's not easy, but you guys are doing great, and we will keep moving forward with this, and we are almost done. So have a great day.